Hello and welcome back. On 7.4 we get to play with trigonometric identities. So remember, an identity is an equation that's true for everything in the domain. So for example, 3x minus 7 equals 11 is a conditional equation. But 3x minus 7 equals negative 7 plus 3x. That's true for all of the x in this domain. This is an identity. And we've seen some identities so far. We've seen that like tangent is sine theta. Tangent theta is sine theta over cosine theta. We've seen cotangent theta is cosine theta over sine theta, and so on. We've also seen a few of our Pythagorean friends. So we saw sine squared theta plus cosine squared theta equals 1. That one, if you'll recall, we'll just take a very fast run through that one. So we'll call this x, y, and r. So sine squared, sine is y over r, so y squared over r squared. Cosine squared is x squared over r squared. So that's y squared plus x squared over r squared, but since this is a right triangle, x squared plus y squared is r squared. So that's why we're equal to a 1. And you can make some other arguments without needing the x's, y's, and r's. Just kind of building off of the sines and cosines to show that, for example, secant squared theta minus tangent squared theta is 1. Remember this one for your Calc 2 class. This one's really super duper handy there. The next one too as well. So secant squared, 1 over cosine squared theta, tangent squared sine squared theta over cosine squared theta. So they have a common denominator, so that's 1 minus sine squared theta over cosine squared theta. But using this first identity, 1 minus sine squared theta would indeed give you the cosine squared theta back. And we have the sort of buddy of this one, cosecant squared theta minus cotangent squared theta is also a 1. So 1 over sine squared theta minus cotangent is cosine squared theta over sine squared theta. That's 1 minus cosine squared theta over sine squared theta. And by just our first Pythagorean identity, 1 minus cosine squared would indeed be the sine squared. So you have sine squared theta over sine squared theta. Remember those two on your Calc 2 days. It'll make your life easier. Those come in handy. We also saw a little bit of work about opposite angles. Sine of opposite of theta was equal to the opposite of sine theta, but cosine of opposite of theta was the same as cosine theta. And since sine switches but cosine doesn't, tangent would switch. If you want to see it out the long way, just once, opposite of theta over cosine, opposite of theta, opposite of sine theta over cosine theta, which is opposite of tangent theta. and their reciprocals work in a similar fashion. The reason sine and cosine work the way they do, if you'll recall, if this is our angle theta and we have our x, y values, opposite of theta would be down here, but the x coordinates would stay the same, the radius would stay the same, the y value would flip. That's why the sign flips. So again, those are some of the identities that we've gotten to play with already. Let's see, they might ask us to do things like simplify secant theta over tangent theta. When they ask us to do this, I like to just turn everything into sines and cosines and see where the chips fall. So secant, remember, is the reciprocal of cosine. Tangent is sine over cosine. And divided by a fraction, multiplied by its reciprocal. Cosines drop, so 1 over sine theta, which is cosecant theta. So the cosecant theta is the same as secant theta over tangent theta. Let's see, next they have us doing some operations. They have us doing tangent theta plus sine theta over cosine theta plus cotangent theta plus cosine theta over sine theta. So first, if you're adding with fractions, whether you're in just an arithmetic class, my apologies, couldn't see the cosecant on the end there. Whether you're just in an arithmetic class starting to learn about fractions, or trig learning about all this crazy stuff, you adding or subtracting fractions, you gotta have your common denominator. So we'll hit this first fraction top and bottom with sine theta. Second fraction, top and bottom with, of course, cosine theta. So I hit this top and bottom with cosine, this one top and bottom with sine. Alright, if I'm looking to do a little bit of simplifying, I can maybe do a little bit of distributing here. So sine theta, tangent theta, plus sine squared theta, plus cosine theta, cotangent theta, plus cosine squared theta, over sine theta, cosine theta. Right away I see sine squared plus cosine squared. There is a nice, neat, pretty one for us. So we have 1 plus sine theta, tangent theta, plus cosine theta, cotangent theta, over sine theta, cosine theta. So since I can't factor a sine or a cosine from the numerator anymore, that's as far as we really need to take that one. Sometimes we'll have a little bit of factoring that we can do to simplify something. So for example, if they give me cosine squared theta minus 1 over cotangent theta cosine theta minus cotangent theta, I can do a little factoring both top and bottom. This is sort of that form u squared minus 1, difference of perfect squares. So upstairs I can turn that into cosine theta plus 1 multiplied by cosine theta minus 1. Downstairs, we can factor the cotangent of theta, leaving us cosine theta minus 1. And I can drop the cosine theta minus 1s, and we can turn this into cosine theta plus 1 all over cotangent theta. It's a messy plus sign, sorry. All right, so the next thing they have us doing is doing work establishing an identity. Not too different than what we've been doing with these, of just doing some manipulating and using some of our other identities like the sine squared plus cosine squared to make things a little bit simpler. The one key difference between this and, say, any equation solving that we've been doing before is we cannot use properties of equality. The reason we can't do this is if we're establishing the identity, we don't know at the onset, are these things really equal to each other? Now, you might suspect that, okay, given that they're asking me to prove this, that yes, they're probably convinced that it's right. That doesn't mean we can rely on that if they're telling us to be the ones to prove that it works. So basically, we have to pick one side and manipulate it. So our first identity we're asked to establish, we'll try sine theta cosecant theta minus cosine squared theta, and we'll try to show that that's equal to sine squared of theta. To me, it looks like there's more action on this left side, so that's the one that I'll start playing with. So I'll grab that sine theta cosecant theta minus cosine squared theta, and we'll just sort of see what we can do with it. So cosecant, again, anytime I see cosecants, secants, tangents, cotangents, I like to turn those into sines and cosines when I'm establishing identities. So that's sine theta cosecant is 1 over sine theta minus cosine squared of theta. Sine squared theta over sine squared theta is 1. 1 times 1 is 1. So now we're equal to 1 minus cosine squared theta. And that is indeed equal to the sine squared of theta. And that's what we wanted to get at the end. So that's where you can say, yes, we've proven that. All right, so the next one we'll play with, again, the directions on all these for the foreseeable future in this section are going to be establish the identity. So we'll try to show that cosecant to the 4th theta minus cosecant squared theta is worth cotangent to the 4th theta plus cotangent squared theta. So I'll just work with the left side for starters. Cosecant to the 4th theta minus cosecant squared theta. One thing I notice I can do is pull a cosecant squared theta. So far, so good. Now we're going to use the fact, recall that cosecant squared theta minus cotangent squared theta was 1. So cosecant squared theta then is 1 plus cotangent squared theta. So that's our replacement for this guy. Again, cosecant squared theta, 1 plus cotangent squared theta. And then we also had this minus 1 here. plus 1 and minus 1 will drop. So now we have 1 plus cotangent squared theta times cotangent squared theta. So that's cotangent squared theta plus cotangent to the fourth theta, and addition is commutative. Now I've gotten to my right hand side. Now we're done. Alright, so next one we're going to prove cosine theta plus 1 over cosine theta minus 1. We're going to show that that's the same as 1 plus secant theta over 1 minus secant theta. So this one, we're going to use the left-hand side, and since we want these to end up looking like this, I basically want to have a 1 here, so I can multiply top and bottom by 1 over cosine theta. And if I do it to the top, I'll also do that to the bottom. So then we distribute. Cosine theta times 1 over cosine theta is 1. So I have 1 plus 1 over cosine theta. Downstairs we have 1 minus 1 over cosine theta. And 1 over cosine theta is indeed equal to, excuse me, I'm running out of room here. It's equal to the secant of theta. That is our right hand side, so we're done on that one. Alright, so next one, we're going to show that 1 minus cotangent squared theta over 1 plus cotangent squared theta plus 2 cosine squared theta is always going to be worth 1. Alright, so obviously a little bit more work on the left hand side. And I want to get these written in terms of sines and cosines. So 1 minus cosine squared theta over sine squared theta over 1 plus cosine squared theta over sine squared theta plus 2 cosine squared theta. So now I'd like to get rid of the fraction within a fraction thing, so I'll multiply top and bottom by sine squared. So sine squared theta over sine squared theta. So now I have sine squared theta minus cosine squared theta. So the sine squared's dropped. Downstairs, distributing, first one I have a sine squared theta. Hang on to the plus sign, distribute to the second one, and the sine squareds drop. I have cosine squared theta, and our plus 2 cosine squared theta is still along for the ride. Sine squared plus cosine squared, there is a 1. So now I just have sine squared theta minus cosine squared theta plus 2 cosine squared theta. So now I have sine squared theta, and minus cosine squared theta plus 2 cosine squared theta is plus 1, or plus 1 cosine squared theta, or just plus cosine squared theta, and that is indeed equal to Alright, so this next one will show sine cubed theta plus cosine cubed theta over 1 minus 2 cosine squared theta is the same as secant theta minus sine theta over tan theta minus 1. This time, I'm going to switch it up. I'm going to take a look at this right-hand side. Then I'm going to turn everything into sines and cosines. Secant is 1 over cosine. Hang on to the sine. Tangent is sine over cosine. Now, I'm going to try to get a common denominator going. So I'll hang on to the 1 over cosine theta, but now I have sine theta, cosine theta over cosine theta. Downstairs, sine theta over cosine theta minus cosine theta over itself. So each of these we hit top and bottom with cosine theta. So up top, now I can write it as 1 fraction. On the bottom I can also write it as 1 fraction. So up top I have 1 minus sine theta cosine theta over cosine theta. Kept the common denominator. On the bottom, sine theta minus cosine theta over the common denominator, cosine theta. So now we'll turn this into multiplying by the reciprocal. So now we have 1 minus sine theta cosine theta over cosine theta times cosine theta over sine theta minus cosine theta. Cosine theta's dropped, so 1 minus sine theta cosine theta over sine theta minus cosine theta. I'm looking to build this up, so next I'll multiply by the conjugate of that denominator. So this one's a little bit longer than some of the other ones. So 1 minus sine theta cosine theta. We'll hit that with sine theta plus cosine theta. We'll do the same thing at the bottom. Sine theta minus cosine theta we'll hit with the sine theta plus cosine theta. Alright, so foiling it out, sine theta. First times the first, outside times outside, plus cosine theta. Inside times inside, minus sine squared theta cosine theta. And last times the last. I don't have enough room there. We'll go below. My apologies. Sine theta plus cosine theta. So first outside, inside, minus sine squared theta cosine theta. And last, minus sine theta cosine squared theta. And downstairs, sine squared theta, plus and minus the same thing, drop, and minus cosine squared theta. All right. Over here. Running out of space there. So let me start with the denominator since that one's a little faster. Sine squared minus cosine squared. Our goal, if you recall, we're looking to get to 1 minus 2 cosine squared. So I'm looking to get that sine squared out of there. So the sine squared from our previous page down here, I'm going to replace with 1 minus cosine squared. Now remember, we also had a minus cosine squared, so I'll bring that along as well. So our denominator is just about there. The numerator, a little bit more work. So we have sine theta. I'll just bring that along. That one's kind of plain Jane, not much you can do with that. But instead of the, I'll bring the cosine along. Bring the cosine along as well. Instead of the sine squared, we'll do 1 minus cosine squared. And that sine squared was multiplied by a cosine. Then we had a minus sine theta times cosine squared. Again, I'll turn this cosine into sine, so minus sine theta. Cosine is 1 minus sine squared. Okay, so our denominator is all dialed in. We have 1 minus 2 cosine squared theta. That's what we wanted. Upstairs, sine theta plus cosine theta. We have minus cosine theta. So I'm distributing the minus and the cosine. And then we have plus cosine cubed theta. We'll do the same thing here, distribute a minus sine theta. So minus sine theta, and then plus sine cubed theta. Well, you might notice sine theta minus sine theta, goodbye to those. Cosine theta minus cosine theta, goodbye to those. So upstairs we're left with cosine cubed theta plus sine cubed theta. Downstairs, 1 minus 2 cosine squared theta. So there's our end result. Not all of them are quite that long. All right, this next one, final one of this section. It's not long as in the last problem of many, many steps, but it's long physically as in they have a lot of stuff on the left-hand side and not much on the right-hand side. So I'm going to go ahead and turn us 90. All right, that should be enough room. All right. So we're going to show tangent of alpha plus tangent of beta by 1 minus cotangent of alpha cotangent of beta plus cotangent alpha plus cotangent beta times 1 minus, can't see any of that. All right, cotangent alpha plus tangent beta, 1 minus cotangent alpha cotangent beta plus cotangent alpha plus cotangent beta, 1 minus, that was continuing on with the tangent, 1 minus tangent alpha, tangent beta, we're going to show that this whole thing ends up as a big fat 0. Not all of them will also be this physically long. But we'll start by just foiling these out. But remember, tangent and cotangent are reciprocal, so when we multiply tangent and cotangent the same thing, we get a 1. Alright, so 2 terms by 2 terms, we're going to FOIL this out. So tangent alpha by 1 is tangent alpha. Outside, tangent alpha by cotangent alpha, that's a 1. 1 times cotangent beta is cotangent beta, so minus cotangent beta. Inside, we have plus tangent beta. And last times the last, we have tangent beta times cotangent beta. That part's a 1, so we have minus cotangent of alpha. So there's our FOIL for the first bit. Second bit, same deal. FOIL them out. So cotangent alpha times 1 is cotangent alpha. Cotangent alpha times tangent alpha, those are reciprocals. There's a 1. 1 times negative tan beta is negative tan beta. Inside, 1 times cotangent beta is cotangent beta. And last times the last, cotangent beta times tangent beta is a 1. 1 times minus tan alpha is minus tan alpha. We're going to show that that's equal to 0. Well, I have a, I'm going to just number these since they're kind of all over. Tangent alpha with minus tangent alpha, end of the line. Those are gone. Minus cotangent beta and plus cotangent beta. Those are gone. Plus tangent beta, minus tangent beta. Those are gone. Cotangent alpha minus cotangent alpha with a plus. That does indeed equal 0. Like I said, not all of them are quite that long. Alright, so let me spin us back around. So in 7-4, I would recommend trying 11 to 95 every other odd. So do 11, skip 13, do 15, skip 17, etc. If you have any questions, please feel free to get in touch with me, and I will see you next time. Stay safe out there.